it's really designed to do? You're going to see shortly, we're going to divide radicals. You know, you say dividing radicals. Like, for example, you can have the square root of 2 divided by the square root of 3. You know, to divide radicals. No, let me show you. There's going to be a format here. So dividing radicals, let me tell you guys something here. This is also known as, this process and procedure is also called rationalize the denominator. Okay, so you have two things here. You have a numerator, that's on top. Let me change the color. You have a numerator divided by a denominator. The one on the bottom, the square root of 3, is irrational. Is that right? Remember that? So down here, to let you guys know, this is an irrational number. That's the square root of 3. We want to make it rational. We want to get rid of the radical. So here's what you guys do. Let me tell you guys this. See if it's true. Do you guys know, if I multiply 1 to any number, isn't it equal to the number itself? All right. Isn't anything divided by itself 1? Yes. So what I'm going to say to you guys here, this is what you're going to do here with these questions here. You want to find a term to put in the top and bottom here, so that when you actually multiply, you get rid of the radical on the bottom. Now, it's actually very simple. This is always going to be the term you guys use here. You see what's already down there, the square root of 3? Here's what I'm going to say to you. Multiply the top and bottom by square root of 3. I can do that because the square root of 3 divided by square root of 3 is the number 1, and 1 times anything is itself. Okay, you guys okay with that? Now, do you guys remember how you multiply fractions, right? How do you multiply fractions? If I said to you, you got A over B times C over D. Do you guys remember how to multiply two fractions? Yes, but we have to be careful here. What kind of across? Horizontal across. Horizontal, meaning A times C over B times D. So what this does is it says, this is the square root of what? Square root of 2 times the square root of 3, square root of 3 times the square root of 3. This is how we're going to multiply now. Square root of 2 times square root of 3 is 6. You guys agree with that one? But what's the square root of 3 times square root of 3? Just 3. Good. What do you guys know about the number on the bottom here? Is it rational? Is there no radical? Yeah, there's no radical down here. That's what you want. This is now what's called a rational number on the bottom. This is rational. So this is sometimes called rationalize the denominator, or you can call it simply division, because this is a division sign. This is to divide radicals, really to divide square roots. So that's kind of where we're at, is dividing square roots, ladies and gentlemen. Okay, you guys okay with that one? What do you think? Is that easy? Easy breezy, fresh and squeezy? I don't know if that's the term. Easy. Yeah, you're trying to get rid of that square root. Not from the top. So let's see if you're awake. What do I multiply both top and bottom by? Square root of 5. Yes. That's the same fraction. So this is the square root of 2 times the square root of what? What's the square root of 5 times? And then you have square root of 5 over here times square root of 5. Okay, you guys see what I'm saying? You're going to use the multiplying fraction algorithm. All right, you're going to use that multiplying fraction algorithm. What does that give you now? What's 2 times 5? Square root of 5 over square root of 5 is what? 5, there you go. Try to move it. Yeah, let's see something like that. So the question is going to be this. What if you had something like this? 4 over the square root of 5 now. Right? Okay. Well, again, what do? Right? You're going to rationalize the denominator. So you're going to multiply top and bottom by what? Not 5, by the square root of what? 5. Good. By the square root of 5. Good. So this is 4 times the square root of 5 over square root of 5 times the square root of 5, because you're going to use your multiplying fraction what? Algorithm. It just so happens, what's 4 times the square root of 5? That's just what? 4 square root of 5. Good. And then square root of 5 times square root of 5 is the number 5. So now you are done, ladies and gentlemen. You're dividing here. So what do you guys think? Is that okay? Six over the square root of x now. Okay, what do you do here again? Multiply by the what? Square root of x. Good. Always that radical. So this is 6 times the square root of x over square root of x times the square root of x. So I hit 6 square root of x over. What's the square root of x times square root of x? There it is. There it is. What do you guys think? Is that okay? What if you had the square root of 6 over the square root of x? Compare and contrast. So far, it's the exact same algorithm, right? Square root of x, square root of x. Multiply diagonally across again. Square root of 6 times the square root of x over square root of x times the square root of x. This is now going to be the square root of 6 what? X over x. Okay, is that true? You guys okay with that? You use the product rule here. All right, good. What do you guys think? Is that easy? Two over the square root of 5 plus 4 here. Now, what do you guys see here for the first time here? Yeah, on the bottom, you don't just have a single radical anymore. Is that right? Notice what's going on the bottom here. You got this square root of 5 plus 4. So you're going to say to me, Mr. Judge, what happens when there's 2 terms here? Not 1. All these examples had exactly 1 term, like the square root of x. Right? Square root of x, square root of 5, square root of 5, square root of 3, What do you do now to rationalize? How do I get rid of the square root? No, we're going to use, you might, if you say to me, I know, I'm going to do what you did before. I'm going to put the square root of 5 plus 4 here. But I'm going to say to you, don't put the square root of 5 plus 4. You're close. Put the square root of 5 minus. Does anybody know why you do that? Well, because when you multiply, let's take a look. Right? This is 2 times the square root of 5 minus 4. Here's my point to you on the bottom. When you multiply, what do you think is going to happen here? Even though technically they're not conjugates, it's not an easy breezy, fresh and squeezy situation. Doesn't your radical go away anyway in the O and I term? It will. Okay, now if you say, I don't believe you. Well, if you don't believe me, use what? Use FOIL. Okay, you guys see what I mean? Use your FOIL, your tin foil. Multiply, you know, at this point, square root of 5 times square root of 5 is going to be what? 5. Square root of 5 times minus 4 is minus 4 square root of 5. That's be 4 square root of 5. This is a minus 16. Is that true? So double check your FOIL boxes, because your FOIL boxes here, the point I want to make is first, outer, inner, and last, the O and I terms will go away. That's what I just remarked. And the denominator now is going to be 5 minus 16. What's 5 minus 16? Negative 11. Is that true? Okay. But that's your denominator. So the bottom here, this is 2. Square root of 5 minus 4 divided by negative 11. So that's going to be, now you might say, how do I see this in back of the book? They'll put negative 2 square root of 5 minus 4 over the 11 in back of the book. And you might say, well, what did they do with that? How did that work, right? All they did was bring up this negative sign. That's all they did. I would, if you leave it down there, I wouldn't mark it wrong. But if you look in back of the book, you might go, wait a minute, why did that sign go in the middle? You know why it went in the middle? What's a positive divided by a negative? It's negative. Yeah, all you got to do here is this. What's the moral of the story? Use what down here? FOIL. Mm-hmm. For the bottom there. Use FOIL on the bottom down here. So now you get it. In other words, use FOIL here is what the remark is. Anyway. Well, here's what I'm going to do here. Let's do this. Go back to the website. Here's what we'll do. You're not in the calculus class yet. You will be. Let me show you guys here. 125. Worksheets and videos. You guys know what this is called? Take a look. Yeah, dividing radicals. It is also rationalizing the denominator here. Okay? Now, we're not done with all of these yet. We're not done, but I'm going to assign them to you now in case you want to look forward to do them. Wonderful. Let's say 1, 3 over the square root of 2. Did we do that one already? That looks like it's already, that looks familiar. How about square root of 3, square root of 5, 3. 6 over, we're looking at some of these there. Okay. Let's go to 7 plus 3. 4. Let's go to 2 over. Let's go to 7 plus 3. 5. 1 over. Let's go to x minus 4. And 6. 1 over the square root of 3 plus the square root of 2. All right. We're going to warm up today with some division questions or some rationalizing the denominator. We'll put our clock there and we'll see what you guys get. This is a warm up. Let's get nice and warm. Okay, ladies and gentlemen, let's try this out. What do you guys think? Weren't these kind of questions we were working on last week? So for the first one, let's do the first two at the same time. Okay? So what did we see last week we had to do? Remember? There's a single radical down here, a single radical down here. You are dividing, but this is also known as rationalizing the denominator. So I'm going to take that radical on the bottom. Remember, square root of 5, square root of 5. We multiply top and bottom with that, right? And then remember what we did last week? Remember I gave you guys this? A over B, there's one fraction, right, times C over D. Here's another fraction. How do you multiply fractions? Straight across, which is A times C over B times D. So what that gives you here is 3 times the square root of 5. And what else did I give you guys last week? You guys remember I gave you another fact too. Remember? Here's what you guys are going to use. The square root of anything times the square root of itself, doesn't that remove the radical? Okay? So what we're doing here, ladies and gentlemen, is using this information for those first two. So the square root of 5 times the square root of 5 in the bottom, the denominator down here, right? What does that give you here? Isn't that just going to be a 5? And so, ladies and gentlemen, you're done, and you use the ideas we talked about last week. This is over. And what do I mean by rationalize the denominator, right? Rationalizing the denominator, pay attention down here. The denominator does not have a radical. There's no radical. Since there's no radical, no square root, this is now rational. So you rationalized the denominator. Now, compare and contrast. When you multiply the numerators together, now you got the square root of 3 times the square root of 5. What's that going to give you? Square root of 15. Now, the square root of 5 over the square root of 5 is just what? Now, is the numerator radical simplified? Yes. So, ladies and gentlemen, you're done, and this is what you would see as your answers. Notice the denominator. Down here, 5, same thing. There's no radical. It is now, we call that what? Rational. It's rational. You rationalize the denominator for number 2. Number 3, number 4. Now, what did you guys remember last time? Did you guys remember? This is where it's new. Yeah, down here. We're doing, remember, this is 2 terms now with 1 radical, so this is going to be here. Here's what you guys use. Square root of 7 and 3, but what's different here? Outstanding. The sign there has to be different. Has to be opposite this plus sign. So pay attention to this, and this is what goes on top and bottom. The exact same copy, negative 7, square root of 7 minus 3. So there you go. And you do that for both of them. Okay, so I want to point out to you to compare and contrast here. Outstanding here. Right? It just so happens in the first one, now you're going to do this multiplication of your numerators. And I can't seem to get the right color for some reason. Numerator, denominator. So here you go. 6, square root of 7 minus 3. Now, what do you get on the bottom here? Square root of 7 times square root of 7. This is going to be, remember this, only multiply. This isn't conjugates, by the way. Just multiply your first terms and your last terms, because the O and I terms are going to go away. Okay, so what's the square root of 7 times the square root of 7? Is that 7? Is that right? And then what's a positive 3 times a negative 3? Negative what? 9. Now, maybe you said, I don't believe you, Mr. Judge. Okay. If you don't believe me, that's fine. Not everybody believes me. Let me show you that it's true, right? Your rows and columns. So square root of 7 times square root of 7, you know, is 7. Positive times a negative. That's negative 3 square root of 7. Positive times a positive. 3 times negative 3 is negative 9. So remember what I'm saying here. First, outer, inner, and last. Don't your O and I terms go away? Right? And then what are you left with? 7 minus 9. And what is 7 minus 9? Isn't that negative 2? So you have 6 square root of 7 minus 3 divided by negative 2. So what's 6 divided by negative 2? Is that negative 3? Is that right? So you're done, ladies and gentlemen. If you distributed, that's also okay. So you're good for both of these. There you go. All right. So, ladies and gentlemen, the O and I term went away. This is kind of conjugate-ish. I call this conjugate-ish. It's not technically conjugates, but it's conjugate-like. Yeah. All right, you guys see that there? So we're going to compare and contrast with the other one. Nice. So you might say, how is this change here? Right? This one is going to be, let me get that. We're still going to multiply straight across like we did, but now you get what? Not a highlighter. The square root of 2, square root of 7 minus 3, over, remember this is conjugate-ish, 7 minus 9, which will be negative 2. But you're going to need to do what? Distribute. All right, so you get the square root of 14 minus 3 square root of 2 divided by negative 2 here. So a positive divided by a negative, to let you guys know with this negative sign, what we can do is just simply put it at the same level as our division. There's a 2. Square root of 14 minus 3 square root of 2. And now, ladies and gentlemen, here you go. And there it is. So that negative sign is up there. All right. Now let's take a look. You say, how do we do that with these two now? Copy these. Let's try to compare and contrast again, right? Maybe we'll just do one at a time now. So since you have a difference in the denominator, what did we just learn from the last example? Square root of x and 4. Square root of x and 4. What do you want the signs to be again? Remember opposites, right? So here's a negative sign. You want this to be a plus and a plus, ladies and gentlemen. There you go. And put your parentheses here. Now, when you multiply across here, you get 1 times the radical square root of x plus 4, because 1 times anything is itself. And then what's the square root of x times square root of x? And then negative 4 times 4 again is going to be what? 16. And ladies and gentlemen, believe it or not, you're done. There's no radical in the bottom. Well, we actually did. What I want to remind people here, that it's not exactly FOIL. It is FOIL. But you go, what do you mean? What's going to happen with the O and I terms like before? What do you guys think happens with the O and I terms on the bottom? They're going to do what? Just like you've seen here. The reason you use those opposite signs is so that your O and I terms go away. It's exactly the reason. So, ladies and gentlemen, let me show you number 6, how that's very similar to number 6. Okay? Number 6, very similar. Square root of 3, square root of 2. And then what do you guys notice about the signs again? The signs are going to be what again? Opposite. Is that right? So that's going to be a what? Minus sign. Multiply your top terms, divide by the product of your denominator there. So this becomes square root of 3 minus the square root of 2 over. Now we're going to use the shortcut. This is what we learned last time. What happens when you have these conjugates? Because these are now conjugates. Do you guys remember the formula from last time for conjugates? What's that going to be? 3 minus what? 2. Exactly. So if you forgot, this is not conjugate-ish. This is directly conjugates. The square root of x plus the square root of y. Square root of x minus the square root of y. What we learned last week is x minus y. So make sure, ladies and gentlemen, you do that homework in a timely manner. Because now this is the square root of 3 minus 2 over 1. And anything divided by 1 is what? Itself. So anything divided by 1 is itself. Here you go. All right, ladies and gentlemen, there it is. So now that we're nice and warm, you say, well, how do we do more of these since we're nice and warm? Well, they can give you 4 over the square root of 5 plus the square root of 3 now. And in that case, once again, what do you guys do? Square root of 5, square root of 3, square root of 5, square root of 3. The sign is now what? Yes, it's going to be negative. Good. Okay, put those parentheses. It's going to help you when you multiply straight across, I think. Here you go. Four times the square root of 5 minus the square root of 3. Everything over 5 minus 3. Huh? Well, you could. What do you think is going to happen if you use FOIL here on the bottom? Anybody try those questions for homework, hopefully? What happens here since you have conjugates? You remember this formula I just gave you? That's what I just gave you. What happens when you multiply conjugates? It's x minus y. So this would be 5 minus 3. Do you guys know what 5 minus 3 is? What's the difference here? 2. 2 goes into 4 how many times? So you get 2 square root of 5 minus square root of 3 as a final answer. Or you get what? 2 square root of 5 minus 2 square root of 3. You're done. Huh? Yeah, either would be fine. Either's fine. There it is. So even if they gave you a radical, you say, what if they have the square root of 7 now? And you get the square root of 6 minus the square root of 3 here. Right? Use the conjugate. Square root of 6, square root of 3. And again, this is now going to be, the sign here is minus. And then this is going to be now what? Plus here. You're going to use conjugates. So when you multiply the numerators together, the terms that are on top, because you're going to do your algorithm for multiplying fractions, square root of 6 minus the square root of 3, square root of 6 plus the square root of 3. What's the square root of 7 times the square root of 6? For the numerator, do you guys know? Should we put it this way? What do you get on top? Square root of what? 42 plus the square root of 21 over 6 minus 3. Is that true? So what happens now? Square root of 42 plus the square root of 6. What's 6 minus 3? It's 3. There you go. Now, is the radical square root of 42 simplified? Say yes. Square root of 21 simplified? Say yes. All right, you guys okay with that? You ready to try some on your own? Okay, we're going to call this numbers. Well, let me give you another example here. What if they give you 5 plus the square root of 2 over square root of 7 plus the square root of 3. Now, ladies and gentlemen, this is going to get interesting. You still multiply top and bottom by the conjugate, by the cousin here, right? Conjugates. But this time, put parentheses here, everywhere like that, okay? Because you're still going to multiply. So on top, 5 plus the square root of 2, square root of 7 minus the square root of 3. And then you know what's nice on the bottom? Since I have conjugates, what do I get to do in the bottom here? I have conjugates. So what do you think I get to put down? Absolutely. 7 minus 3. Outstanding. And we know what that is. That's going to be what? 4. But the problem is, what do you think you have on top? How do I get that answer on top? Do you guys know? What do I have to use to get that answer? Yeah, so you do have to do a FOIL box on top, but you don't have to do a FOIL box where? On the bottom, only on top. What do you guys think about that? Pretty good? So you might say, okay, what does that FOIL box look like? Well, we're going to have a 5, square root of 2, And then on top we have the rows, right? Well, columns. Okay. All right. So the FOIL on top, so I want to illustrate to you guys. The formula on bottom gave you a 4. Okay, 5 times the square root of 7, isn't that 5 square root of 7? Then a positive times a negative, isn't that going to be a negative? So it's negative 5 square root of 3. Square root of 2 times 7, isn't that square root of 14? Positive times a negative, square root of what? 6. So on the top, I got 5 square root of 7 minus 5 square root of 3 plus the square root of 14 minus the square root of 6. This is what I got by using FOIL on top now. Okay, notice that none of the terms are like. They're all simplified radicals, so we can't combine them. But what's on the bottom? Yeah, 4. So you might say, Mr. Judge, what do I do here with this? Well, you're done. You can leave it like it is. And get rid of this here. There it is. There we go. So let's take a look here. Not there. We want to look at Math 125, but no, decrease. Okay, you guys are in Math here, Math 125. Worksheets and videos. Dividing, rationalizing denominators. These are the kind of materials that you guys work with here. So what I want to do here is I'm going to take some questions here, sort of, just to remind you guys I'm looking at these kind of things. No, I don't want to see that. Let's give you guys some examples. And I guess we'll number these here. Number 6. So this will now be 7. And I'll say they gave you the square root of 6 plus the square root of 2, the square root of 7 minus the square root of 3, 8. Square root of x plus the square root of y over the square root of x minus the square root of y. Okay. I want to give you guys time to try these out. And see what you guys get. Let's give you guys the timer. Try these out, ladies and gentlemen. Okay, ladies and gentlemen. All right, let's try this out here. What I'm going to do is move this down here. We're going to use what? Square root of 7, square root of 3, square root of 7, square root of 3, and this is going to be what sign? Plus. Is that right? You guys see that there? We're going to use, what is this called again? Conjugates. So I'm talking about down here in the denominator, we're multiplying conjugates together down here. So maybe put this one in purple. Right? The bottom, I'm saying, here's going to be our conjugates. And you know what we've been doing, though, let me do it this way. Just to be clear, what we have been doing is this. So let me put it down here instead. Right? Multiplying conjugates together. What's that? What does that mean? Down here, this is 7 minus what? 3. Is that right? Which will be 4, because you go, oh, is that 4? Yes, it is. You're right. But then on top, when we multiply the top portion, are these conjugates? Say no, you have to use what here? Foil. Good. We're going to have to use foil now. So we get out a nice foil box. Square root of 6, square root of 2, square root of 7, square root of 3 now. All right, ladies and gentlemen, here we go. What is the square root of 6 times square root of 7? Square root 42. Square root of 6 times square root of 3. Square root of 18. Square root of 2 times square root of 7. Square root of 14. Square root of 2 times square root of 3. Square root of 6. And what do you guys notice about this radical here? That's the only one that you have to simplify, because this is what you get by FOIL. This is first, outer, inner, and last. So when you simplify this, isn't that 9 times 2? Largest perfect square, and that becomes 3 square root of 2, ladies and gentlemen. Okay? So the IO term is 3 square root of 2 now. All right, bring everything down here. Square root of 42 plus the 3 square root of 2, the radical that we just simplified, plus the square root of 14 plus the square root of 6. Notice you cannot add any of those terms. Is that true? Okay, but what is what is that? 7 minus 3 again. This down here is 4. So, ladies and gentlemen, you're done. There's no radical in the bottom. This is why they call rationalize the denominator. What do you guys think? Is that okay? Is that terrible? It's not too terrible, right? Was number 8 terrible? Did you guys have all this here in your notes? Double check. Is that one okay? All right, now, what's the conjugate down here? Square root of x plus the square root of y. Is that right? Okay, so I'm writing it down because this is how we multiply two fractions. It just so happens in the denominator position, once again, we have conjugates. So what does that give you? X minus y. Outstanding, because these are conjugates in the denominator. But the numerator is a different story. Is that right? You don't have conjugates in the numerator, and again, you're going to have to use FOIL in that numerator. So, ladies and gentlemen, let's take a look. Okay, now let's see. What's the square root of x times square root of x? Okay, square root of x times square root of y. Okay, square root of x times square root of y again, or square root of y square root of x is the same thing. Is that true? All right, what's the square root of y times square root of y? So I want to remark to people, this is your first, outer, inner, last due to FOIL that we just did here. Multiply your rows and your columns. So that numerator is x plus square root of xy plus square root of xy plus y. The denominator is over x minus y. But what do you guys do with these two terms here? Don't think you add them, right? So it's really 2 apples. So, ladies and gentlemen, this is dividing again, radicals. Huh? Yeah, because the numerator, combining like terms, nothing combines in the numerator. And remember, you also call this rationalize the denominator. That's code for no radical on the bottom. This is actually why you're using the conjugates to get rid of the radical. So there's no radical. This is why they call it rationalize the denominator. So like what I'm saying here is this. If I go back to the browser here, right? This section,